Welcome to Academic Digest class. Today's video I'm treating friction. So we're going to be looking at friction, reason for friction, types of friction, comparison between limiting friction and kinetic friction, coefficient of friction, laws of friction, causes of friction, reduction of friction, advantages of friction, horizontal friction, inclined plane friction, that is friction at an angle, that is the aspect of friction that involves calculation. Then after this, we'll now do another video that involves solving our questions on this. So what I've done is that I've taken my time to group all the things you find under friction. So let me look at it one at a time. So friction, I normally tell my friends and my students that friction is simply the force opposing motion. Another way to look at friction is that it is negative force, or you say it is resistance or resistive force. So it moves in opposite direction. It always moves in opposite direction to where the forward force is going. So if you know this, let's move to the second part, types of friction. Reason, or you say cause. So the main reason for friction is that no two surfaces are exactly smooth. So even the surface that you think they are very smooth, on a microscopic level they are not. So no two surfaces are exactly smooth. That's why. So the reason for friction is actually roughness, be it on a large scale level or on a microscopic level. So it's roughness that causes it. So you've noted that I have many things going on in my head, but I want to keep it simple. So the next one is types of friction. We have the static friction and the kinetic friction. Static like this and kinetic friction. So static friction, I take my time to write all these things because I know JAMB students are also watching. So we say static friction is the friction of a body at rest, or you say when it is still at rest. So you can say the friction of a body at rest. So if you know this, it simply means that before the body starts moving, it also has friction, and that friction will even be more, because if this surface is very rough and I keep a ball on it, let's say this ball has minute spaces or minute roughness on it, and this table has minute surfaces, before it starts moving it's very glued, unlike when it has started moving. So if I know this, I now go to the next one, which is kinetic friction. I will say that kinetic friction is the friction of a body that is in motion. Friction of a body in motion that is in motion. So the next one is, they said we should make comparison between static friction. Notice I've not given any equation. Sorry, between static or limiting friction. I want to use limiting friction because this is the one you come across, and kinetic friction. Alright. We said that limiting friction, I've not given any formula. For you that want us to dive into calculation, you will see the video, the next one. This one is for you to understand what I'm doing. So that limiting friction is the maximum static. Some people always classify it as another friction. No, it's the maximum static friction of a body uh, just before it starts moving, or just before it enter kinetic friction, just before it starts moving. So the maximum static friction just before. So because when that body is at rest, the rough surfaces are higher compared to when it has started moving. We say that limiting friction or static friction is actually greater than kinetic friction. So we already know what kinetic friction is. So when the body is already in motion, for example, when you see a chicken and they are cutting the chicken, if you do that knife fast, in your eye you feel like the chicken tends to feel lesser pain compared to when that knife has to go through the chicken's throat gradually. Yeah, pain is pain, but I'm just using it as an instance. So he's saying that if the surface is the main reason of friction is because of the roughness. So if they're at rest, their roughness is higher. It starting from rest tends to be require much more application of force. But when it has already moved, as is in motion, those surfaces are still rough, but their contact is not that strong to require big force compared to when it was at rest. So that's it. So we move to the next one. I want to do the next one here. The next one is laws of friction. If you know my way of teaching, you understand that I don't dive into calculation first. I make you understand. Then in our next class on this, it will now be all about calculation. So laws of friction. So we have a video. Check our video on everything calculation, all the formulas. I will do all the formulas here, but how to use it. Laws of friction. The first one is that frictional force, yes, is directly proportional. Frictional force is directly proportional to normal reaction. So this is why I did not introduce these formulas. So if this is frictional force, it is directly proportional to normal reaction. And I always use NA for my normal reaction. So I hate using this R. N. So F directly, small f for friction. So if you put equality sign, it will now be mu this like this to this. So if it is static friction I'm talking about, it will be F equals to mu, limiting this mu now is coefficient of static friction. It will be here and N. If it's kinetic friction, it will be mu, then it will carry K, then you have N. So if I've noted this, I move to the second law. So the second law is that friction is independent of the area in contact, or of the area of surface in contact. What this thing means is that area simply means vertical and horizontal. So if the surface, like, let it be circle, or let it be block, or let it be rectangle, let it be square, or let it be triangle, let it be small or big, friction does not look at it. It will still occur. It will still occur there. So it will still occur the normal way it should occur. It will not say let me be small because the surface is small, let me be big because. So it's independent of the area, or you say it's independent of the quantity of the surface or the amount of surface. Why? Yes, so it's independent of the quantity of surface, but it is dependent on the quality of surface, which we call nature of the surface. So friction is dependent on the nature of the surface in contact. So if the surface is very rough, equals high friction. So very smooth does not mean no friction, but less friction, because we say in physics that nothing is smooth. The way we say nothing is straight line. So we say nothing is smooth, but very smooth, less friction, because on microscopic level, those things that appear smooth are still rough. So very smooth, less friction. So it is dependent on the nature. If it is very lubricated, you feel the friction a little, or to a point where it feels like there's no friction. So that's number 3 law. Then the 4th law is that friction opposes motion. So what causes motion most times is force. So for that reason, this is where we get the general force, the general formula we use for horizontal, for that is, or you say friction obeys the law of forward reaction. Action equals to, for every action there's normal reaction. So uh if you apply action like this, let's say forward force, so friction will tend to go opposite. If I kick something, I will feel a backward force. So friction is a backward force. Friction opposes motion, or you say it is a backward force. So but I want you to not go and be focusing. If they tell you something is dragged with 20 Newton force, if that 20 Newton force there is the forward force, don't go and be checking the frictional force there. What you'll be checking is the friction on the particular body that forward force is applied to. For example, if I have a block now applied that is here, and this block is 8 kg, and I have to pull it with a force of maybe 2 kg, this thing here is simply 2 times 10, 20 Newton. I am not checking the friction here because I'm pulling this thing. Where the friction is going to be affecting is the motion of this object. So if I'm checking the friction here, I'm simply going to be doing mu mg on this. That is mu, whatever they give me as the coefficient of this, then I'm going to be having, remember when we did this thing, is always having that mu. So I'm going to be having 8 times 10, which is mu 80 Newton. So this is where I have my friction equals to. So anything I am checking here, when I'm checking anything here, if I want to calculate this now, it will simply be this forward force, which is 20 Newton minus minus friction, which is mu 80 Newton, is equals to the total force F net. So if you want to check, always do it this way. So that one that you are giving that moves it is the forward force. You don't go and be checking friction inside forward force. No, friction affects objects that is moving. So your eye should be on the force or on the mass of that object, the opposite. I know if you see calculation questions, you should be able to get this point, but it's that simple. And this is when we are thinking of horizontal motion, because notice is moving this way. So we say it's friction on horizontal direction. So from this law, we get friction opposes motion, which is, that means that this is F forward minus backward, Newton's third law, equals to ma. And a situation whereby it's not each case is, so let's say first case, so let's say in a case where there is no movement, like it is still at rest for static friction, so Fs for static friction, there will be no acceleration. So this will be m times 0, which means that everything here will be 0. So F minus Fs equals to 0, which means that F will be equals to Fs, static friction. That means F will be equals to mu mg, mu smg. So when you hear a question, or when you are given a question and that question says about to what is the force to enable it to move, or what is the force when it is at rest, what is the frictional force when it is at rest, or they tell you what force will be applied to enable it to move, this is what you are using. So the force there will be directly or will be equals to the frictional force, and this is the reason because of this. But a situation where you have kinetic energy now, so you have, sorry, where you have kinetic friction is already moving, this will be F minus Fk. Because it's already moving, we have an acceleration, so this will be equals to ma, whatever you are given. So in this case, this is how you do it. This is how you do it. This is what it will be. This is how it will be. But a situation whereby maybe you have an elevator question, In an elevator question, if it is going up, you remember that you are having mg plus ma in this case. So sorry, I don't want to start teaching you elevator here. While if it's going down, you have mg minus ma. So you check my class on dynamics elevator questions. So but if you apply it to this thing, because it's already moving, you are going to be having F, the force, minus Fk is equals to, since it is going up and down, the A here, should be G. So it will be mg. But because as it's going up, the elevator is going up and coming down, acceleration will be there. So you now have plus A. So in a case where they give you an elevator question, you are likely going to be using this particular one. So remember, all these things falls under horizontal motion. Okay, all this falls under friction, that is horizontal friction. And still remember, we are dealing with the laws. Sorry. So number 5, the fifth law. The fifth law is that static friction will always be greater than kinetic friction. And I've told you the reason, because there is more roughness when a body is at rest than when it is already moving. The surfaces are hardly in contact when it is moving compared to when it is still at rest. So if I know this, we move to the next one, the fifth one. How I've sectioned it. I told you what I did was to draft out all the topics, like from my own observation, experience, and reading. So now let's treat advantage. Oh, sorry, okay. Have I treated? Okay, this is laws of friction. So causes of friction, I've already said it. The surface, roughness of surface makes friction to occur. So yes. So and when then let's go to the next one, to reduce friction, reduction of friction. So it's just like a secondary school. To reduce friction, you do lubrication, lubricating the surface. So lubrication, polishing, all those things they taught in secondary school, polishing, ball and roller bearing. You know, in Nigeria, we tend to do all these things without anybody coming to do something to show us. But in life, as you progress, you will still learn it, God willing. Then you meet things that show you, okay, this is true. So anything that reduces surface roughness, so that is it. So advantages of friction. It has advantage and it has disadvantage. So the disadvantage is the noise you hear. Maybe two things hit. Maybe you see on the road when something apply brake, you now hear choo noise pollution. Or maybe sometimes you see somebody maybe shout or talk much, and at some point the person will have bad throat, or maybe you are not wearing boxer, or you are not wearing strong tights that is long, your two legs rub together, you notice that your laps tend to hurt, that kind of thing. So that's the disadvantage of friction, because they are hitting together, those contacts, whenever there's contact. So advantage is that it helps us walk, like for walking, it's possible for us to hold contact with the ground because of friction. Then writing, as I'm writing now, I'm writing well and my pen is not slipping out of this paper because of friction. So anything that makes two things hold contacts peacefully is an advantage of friction. So the tires on the tarred road, consider as friction. There are many of it, many of it that you can think of. So I can't really start to think or think less or think more, but there are plenty. The advantages are very plenty. So for horizontal friction, I'm trying to do this in time. So for horizontal friction, let's give you all the formulas for horizontal friction. I've given it before, but let me outline it again. So for horizontal friction, you need to know that friction itself is directly proportional to mu n, and n is equals to mg, which means that this is the same way. So whenever it's friction, so this way. And I want you to always look at this. Let me leave it, but this is the first formula for horizontal friction. The second one is if I have a force minus friction, I should have the F net, which is MA. That is, see what I mean? And remember that this is mg minus mu mg equals to MA. Or you just say F minus F equals to F. That is mg minus mu mg equals to the F net. So what this thing means is that forward force minus backward force is equals to the total force. A situation whereby I have two forces and one is forward, one is backward, the total force will simply be forward minus backward. So this thing is functioning as forward from Newton's third law, then backward. So, but a situation whereby from this same law, a situation whereby I don't have acceleration there, that means this will be F minus F equals to 0. Because A here will be 0. So if that be the case, you can now see that this is now looking like the first one here. So you can now say that force itself will now be, if this crossover, it will now be equals to, that means that F here will be equals to mu mg. So in most cases where you have any question related to friction, it is always revolving around this formula. It's always revolving around it. Let me check a question. I think there's one question I solved that looks complicating. So let me check. So if acceleration is there, yes. If acceleration is there, so yes. So please, when you're solving this question, you now need to know that if you are given acceleration, like in this case now, and you want to find force, maybe you are given acceleration and you want to find force here, that means that this will now be, in this case, let's say I want to make this subject formula now. This F now can be equals to the MA that I have on this one, that is here, plus mu mg. And let's say they gave you distance or acceleration. Maybe they gave you distance or they ask you to find something using distance or find something using velocity. All you have to do is to remember that S is equals to ut plus half et square. And in most cases, this is always starting from rest. This is 0. So S is equals to half et square. So you can always use that distance you are given, put here, make a subject of formula, so that you now have 2s equals to at square. So by the time you do divided by t square divided by t square, you've gotten your a. You can substitute it back and get that. Then a situation whereby you have, you remember, you have velocity given v equals to u plus at. You can actually remember this is 0. So by the time you substitute, you now have v over t is equals to a. You've gotten your a. So these are cases or questions that will come across. So when it is on an inclined, so if the formulas are a bit confusing, no problem. I believe when we start solving questions, you understand. But my own goal is to make sure that the class, this elaborating class, has all the things that you should have. So for friction at an angle, I've told you that physics is always looking at the vertical. When you're talking about the vertical, when you're talking about the horizontal, when you're talking about vertical and horizontal at the same time, when you're talking about at an angle z, that is x, y, z, that is z at an angle, and we always do that at an angle using inclined plane. So if I know that for inclined plane, I will always look at it from this angle. Everything I've told you, go and watch my class on an inclined plane to understand it. Everything happening here is mg sine theta. And everything happening this way as well is also mg sine theta. But if something is going this way, going down, it's the same thing as saying the weight down. Then if it's going this way, friction automatically will be going this way. And if you are told that a pulling force was there, pulling force was added to this, that means a situation where there is no pulling force will simply be mg sine theta equals to mg sin theta at equilibrium, or let's say this way, at equilibrium, to keep it at rest, at equilibrium, mg sin theta will now be minus the frictional force that will be going in the opposite direction, which is the same thing as saying equals to mu mg cos theta. But in a situation where you are not taking note that there is a pulling force dragging it, this is actually supposed to be this way. Okay, yes, it's actually supposed to be this way. Mg sin theta. Now, pulling force, because it's going down, so going down, mg sin theta, x axis becomes the forward force. We will now minus that pulling force. I'm also minus the friction, so I just say plus mu mg cos theta will be equals to the total force F net. This is the formula you use when it is going down, because this one becomes the pulling force. But when it is going up, when that thing is, there's pulling force, so but this thing is still going down, you judge it on the fact that the weight is concurrent, is on the right path, that is on the path of going down. The weight is the forward force. But if it's going up, the pulling force is what is making it go up. So pulling force becomes the forward force. So it will now minus the x-axis, the weight downwards, which is mg sin theta. I've told you, I'm not taking time to explain this from scratch because I know I have a video on inclined plane. Mg sin theta minus the frictional force, because if it is going this way, if you are dragging and it's really moving this way, simply means friction will go in opposite direction. So minus, which is the same thing as plus. So mu mg cos theta, and everything here will be equals to the total force. So when it is going upwards, this is your formula. When it is going downward, this is your formula. When there is no pulling force, at equilibrium, this is how you look at it at equilibrium, because see why it is that way. This will be mg sin theta minus mu going in opposite direction g cos theta. So at equilibrium means there is no movement. Equilibrium means no movement, no net force, no net torque. So ma, this thing will be 0. And if this is equals to 0 now, it simply means that you can cross over to become this. So this is the same thing as saying friction, like this. Let's say they gave you a question that has just the friction there already. So, but if you check this now, from this formula I can get the angle of inclination. And another name, so to get angle of inclination, which is also called angle of repose, is simply gotten by doing mg sin theta equals to mg cos theta. Remember mu, that is this. So this will cancel this. So you now have sin theta equals to mu cos theta. Divide both sides by cos theta. Mu will simply be sin theta over cos theta is the same thing as saying tan theta. Mu is equals to tan theta. Then to get the angle of repose, theta will be equals to this crossover tan inverse of mu. So this is how you go about it. So if you know this and you know this, I believe you're on the same page with us. So in our next class, we'll solve questions, because it's not about doing all these things. There are ways that questions can come, you'll be thrown off. So you still make sure to watch the videos on how to get on all the questions, textbook questions. Subscribe to the channel. Bless.